okay, the second part of it. And we will now study things more, like average acceleration, for example. Now, not all the objects, they are moving with constant velocity. They move sometimes with acceleration, most of the time with acceleration. And average acceleration means, okay, means change in velocity per unit time. And it cannot be change in I would say speed. It should be velocity. The reason is I might have acceleration to or like make change in what? In speed. Okay, which is here, I will say the magnitude of the velocity. And here you might have, I will say, either a decrease in speed or increase in speed. Something that I want you to know also, that acceleration, it is a vector quantity. What does that mean? That I can represent it as a vector like this. Now, when we have the acceleration as a vector in the same direction as the velocity, speed increases. And when we have the acceleration in the opposite direction of velocity, speed decreases. Okay? Now, there is another case when I have acceleration, and that is when we're gonna have change in direction. Then if you have your object moving over a circle, even if it was moving with what is called uniform circular motion like this, which means the speed is constant, there is acceleration, and that acceleration is going to be always towards the center. We call it centripetal acceleration, and we're going to talk about this later. But now I want you to know that you should know that about the speed. If it is not changing, but the velocity vector is changing, we have acceleration, which means there is a change in the direction. Now, let's talk about what does it mean to have acceleration, and how we are going to calculate. Then I'm gonna say here I have, by the way, yes, we can write acceleration as a vector, change in v over time, and that is gonna be v final minus v initial divided by time. It has units of meters per second, meters per second squared, meters per second squared like this, and meters per second like this. Now, if I have let's say a checkpoint here, if I have an object that was starting from vi equals 0 and reaching a final velocity that it is 15 meters per second, due west in 1.8 seconds, I can calculate the acceleration to be, I can write v final as negative. Why? Because it is due west. These two information are really equivalent, but when I was in the equation, I should have it as negative. A is going to be v final minus V initial divided over the time, and then it's gonna be negative 15 minus 0 divided by the time, which is 1.8 seconds. And then you're gonna get the magnitude of the acceleration is gonna be 8.33 meters per second with a negative. Then apparently, because my object is moving to the left here, and its initial velocity was 0, then the acceleration vector came up to be in the same direction. And this did cause the object speed to increase in the negative direction. Now also, I want to say we should differentiate between two terms. One of them is, let me do this here for also velocity. When I talk about average velocity versus instantaneous velocity. And I will say here, okay, this is the average for the whole trip. This one, it is just at an instant. Now this one, as I said, we calculated as total displacement divided by total time. This one, we need calculus for calculation, and because we will not be able to use calculus in this course, the only thing that I want you to know is we should be able to calculate it using the graph. And you are going to find, let's say I want to find what is going to be the velocity, the instantaneous velocity here at t equals, let's say, 3 seconds. I should find what is the tangent here and find its slope. And this is going to give me my the velocity of this object. All right? Then we will not use calculus here, of course, because our course, it doesn't have any calculus requirement. Also, we can differentiate between average acceleration versus instantaneous acceleration. Okay, it's the same thing. Okay, now what we need to know also here, that when I have, like also this one, we said we can calculate it, okay, as outlined. Here also, I might have a graph, velocity versus time. And the only way that we should learn in this course how to do this is by finding the tangent and finding its slope to calculate the acceleration. Remember, the first one, it is displacement versus time, and this one is velocity versus time. Now, we will not actually talk about non-constant accelerations, and I will say we are going to have only our course talking about constant acceleration motion. Now, in order for me to describe constant acceleration motion, I need to list equations for you where we can use them. And we have 4 equations. I'm gonna list them first, and then I'm gonna calculate, I'm gonna show you how we are going to use these. Okay, then the first thing is I'm gonna list them. Okay, then the first one, it is V final equals V initial plus AT. V final squared equals VI squared plus 2A x minus x0. Or let's say x final minus x initial. We're gonna use the same notation. And then x final, it is x initial plus 1/2 AT squared. I forgot one term here, which is VIT plus 1/2 AT squared. And also I have this is as one of the equations. Okay, then these are the 4 equations that I have, and I can use them to calculate and describe the motion of any object. Let me explain to you what these and what are the units. Now VF, it is final velocity, and since it is a vector quantity, it can be positive or negative, and its units meters per second. The second one, VI, which is the initial velocity, and it is plus and minus meters per second because again it's a vector. A, okay, A it is acceleration, and it can be plus or minus and meters per second square. Now the only scalar quantity here is time, and time always positive, and it has units of seconds. Now x final, it is final position. I might use a notation different from your textbook, but I'm defining for you these. Like I like maybe to make them meaningful. Then this is can be again the final position. It might be plus or minus, and it has units of meters. And then xi is gonna be initial position, and it can be plus or minus, and it is meters. Now in all these, I have 4 physical quantities. Okay, don't count xi. Okay, therefore in the problems you will get 3 known quantities and 1 unknown that you need to calculate. Okay, and I'm gonna show you how we are going to to do this. Okay, I'm gonna use examples from your textbook. Okay, I will say example 1. A jogger, it's like sometimes it's gonna change into an eraser. Runs down a straight stretch of road with an average velocity of 4 meters per second for 2 minutes. What is the final position taken his initial position to be 0? Okay, always a sketch is very helpful. Then this is the solution. And I said the sketch is very helpful. I can say this is going to be my x. Okay, and okay, I don't care where is my origin. Okay, then here, this is where my object has started the motion. That sugar is here. And then was moving to a point. Oh, yeah, okay. And in the question we said taken to be 0. Then I'm sorry, like, okay, I did not. Okay, but that doesn't affect anything. Okay. Then here, I want to make my position, my origin at like at t equals 0, my xi equals 0. I don't have any initial displacement. And then here is going to reach somewhere here. And I have the average, okay, all over the trip. Now, one thing that I want you to know here, this is a very special case when I have constant, but don't apply it for everything. When I have constant acceleration motion, my V average, it is VI plus V final divided by 2. And as I said, this is a very special one. Then my last equation that I gave you, which is x final equals x initial plus VI plus V final over 2 times t. Okay, that can be written as this. Let me first get rid of this because we know that this one is 0. It's going to be V average times t. Okay, I know that the average velocity was 4 meters. I know that the time that was taken is I think 2 minutes. Then I will say 2 minutes times 60. Not 60 here. I want to convert this. This is really, what did I say? Yeah, this is like 1 minute is going to be 60 seconds. And doing this, I will say that I will have the x final is going to be 480 meters. Okay, then this is really one of the questions that I was able maybe to solve it for you to show you what is really how we're gonna apply. I'm gonna solve another one. Like I have an airplane lands with an initial velocity of 70 meters per second and then decelerates. Decelerates means that the velocity is going to decrease, or you can say actually accelerates. Okay, we can use the same term. What is the final velocity? Here for my solution, I have, this is my positive x-axis. This is my origin. Always, okay, I can take my xi to be 0 at t equals 0, which means like I'm gonna take the origin here. And this is where, you know, how to, like an airplane. This is an airplane. Okay, and it was initially moving with VI equals 70 meters per second. There is an acceleration here. I want to tell you that it should be negative 0.5 meters per second squared. The reason that it is actually in the opposite direction of the motion so that the airplane will stop. And then finally here, okay, I will say, finally, I will say it's gonna stop, but we are not looking for that. We wanna find that after 40 seconds, okay, finally it will stop, but here the question is asking you if t is 40 seconds, we are going to find what is really the final velocity. Okay, now what I will do again, okay, I like always to have that type of box for all my variables. Okay, I have x0 equals 0 and okay, maybe I will not need it. We're gonna see VI meters per second. It is 70, and I am looking for my V final. Okay, time is in seconds. It is 40 seconds, and A, it is negative 1.5. Now, if I looked at the equations that I have, you are going to find one of them that is going to say V final equals VI plus AT, and that is the one that I want to use here because it has all the 4 variables. Then I will say V final is 70 meters per second plus negative 1.5 times 40, and that way I can calculate what is going to be the velocity after this time. Still, it needs more time to stop. Okay, then this is here and there are like more in your textbook that you're gonna practice. If you need, you know, I will say any help, just let me know during office hours. Okay, I'm gonna finish this video also here. And there is one more about free fall. I'm gonna record it soon. Thank you.